All right, class, we have soap here. Soap is actually just a salt of a fatty acid. All right, so you can notice here, this is a fatty acid here. We have the acid component here, okay, COO. You normally an H there, but we're going to put something else there in a minute. Because it's a salt of a fatty acid, we'll do that right now. Put a sodium there, so that's the salt part. Okay, and then here's the fatty acid chain, hydrocarbon chain. Okay, long chain of carbons, goes on further, but I just wanted to abbreviate a little bit. I ran out of room. And every one of these carbons has 2 hydrogens attached to it. The last one has 3 hydrogens. All right, so that's what soap molecule looks like. For Nick Byers, I could also draw it like this, with the acid in there with the salt, and then I could go, and you know at every one of those angles there, you have a carbon attached to 2 hydrogens. Okay, so that's the abbreviation for it. Okay, so there's a couple fatty acid chains. Now when soap gets into water, okay, it tends to curl up like this because the nonpolar ends stick together. So you get a circle like this. Pretty cool. And all those tails will stick inside there like that. That's called a micelle. Okay, okay, so the water's out here, which is of course polar. Okay, water molecules all around it. And then the polar heads here, the acid heads with the salt here, which are polar, they orient to outside. Okay, and then on the inside you have the nonpolar parts. Right? Okay, so that makes it easy to dissolve things. So, example, you get grease on your hands. Okay, you put it into water. The grease does not dissolve, but if you put your hand in that soapy water, wash it with soap, what happens is that grease gets dissolved in these non-phobic micelles, okay? And then the water will wash away the micelle down the sink, and you should have clean hands. Okay, so what we have here is comparison between membranes and bubbles. Okay, so soap bubbles are very analogous to cell membranes. Okay, cell membranes, of course, you can notice this as a phospholipid bilayer with the hydrophilic heads here and then the hydrophobic tails inside. So if this is inside the cell, that would be cytoplasm, which is mostly H2O. And the extracellular environment is generally H2O. So you get the cells aligning like that. In bubbles, soap bubbles, it's just the opposite because the bubbles are in air, and air is chiefly nitrogen, N2, which is N triple bond N, which of course is nonpolar. Okay, and then that's about 79% and about 20% oxygen, which is oxygen double bond to oxygen. So O2, they're both nonpolar, so air is nonpolar. Okay, so when a soap bubble forms, you get the salty acid inside here. The hydrophobic part is inside, and in contrast to bubbles, the hydrophobic part is pointing to the outside. All right, so when you form of course, a membrane, you have a cell, and then you have the, I'll enlarge this a little bit. Here's the, looks like that, okay, with the air bubble, or a soap bubble. Okay, it's like this. You got the circles there, and they go like that. So you have the air inside, the air outside. Okay, so that's how come air bubbles form. Okay, forms the circle of the wagon, so to speak. Make some membranes now. Actually, we're going to make bubbles. Okay, but they are very analogous to membranes. Okay, so I use a 5-to-1 ratio of water to soap. Dawn soap is good. Lemon Joy is also good. If you want to, you can use a little bit of Caro syrup, 2 or 3 tablespoons. Should strengthen the bubbles a little bit. You can also use glycerin if you have that. Trouble with that is it gets things really sticky. If you do it inside, it makes it really slippery. Okay, so that's optional. Okay, I actually use for my solution 10 cups of water and about 2 cups of Dawn soap. Yep, there goes some of it. All right, what else you'll need some straws and some fishing line. Okay, so I made up the soap, put it in this shallow pan. Okay, so I made this little bubble maker here. Right, all you have to do is get some fishing line String will probably work also. Get a long piece of it. Okay, then you just thread it through 2 straws. You can cut the straws down to size if you need to. You can use long ones if you want to be ambitious. Thread it to both straws, then just lengthen it to the length you want. And tie a little square knot in there. And then you do this the knot, you just kind of push it through until the knot's inside the straw, so you have a nice bubble maker there. Okay, also make a tiny loop with the fishing line too for a little project, or a little demonstration within that. Okay, now it's time to make some bubbles, okay, which have that fluid trait like membranes do. All right, so just play around a little bit. You can get your hands all soapy. Okay, one thing you can do is you can make a little membrane right there. Okay, go through it, get a little bubble, a little bit bigger. Okay, okay, then try to release it. You can do this. This is a favorite of some people. Across here. So we got some bubbles there. You can take your bubble maker here. Okay. So a good technique to use there is to go in and then just pull up like this. Okay. And then you have the bubble here. Then you can blow through it, make a bubble. You can just take your straw, blow in, and make bubbles here. Big bubbles in a bubble. Okay. 2 things which will help. One, don't do it on a real dry day. The more humid day it is, the better. So it's kind of dry today, so there's one of my excuses. The other one is that for some reason, if you wait 24 hours till the next day, the bubble solution works better. Right? So I just made this up today, so I'll try again tomorrow. The bubbles should be a little bit stronger. And also, just after you do it a few minutes, it tends to come out better. Okay, so you just stay at it. Make some nice membranes.